Hey everyone, in this one I'll be looking into indices and standard form. This is both included in IGCSE as well as GCSE math from the Cambridge International Examinations Board. And as always, I've listed down the objectives from the syllabi from both of these qualifications, and it's the same for GCSE and IGCSE. It says use the standard form a into 10 to the power of n, where n is positive or negative integer, and a is greater than or equal to 1 and lesser than 10. This is the one that we're going to be focusing on today. And the next one, the rules of indices and interpretation of different types of indices, this is going to be focused on in the next one. So look out for that. But first, I'll draw your attention toward these two words. Have you ever heard them? If you haven't, you might have heard some words like cube, square, in the very basic numbers chapters. For example, I can say 2 cubed and I can say 2 squared. What would that mean? Would it mean 2 into 3? Or would it mean 2 into 2 into 2? 2 into 2 into 2. 3 times 2 multiplied together by itself. If you have selected this option, this one is correct. So if I say 2 square, that is going to mean 2 multiplied by itself. If I say 3 squared, it's going to mean 3 into 3, and so on. This value right here, it's called the base. Right here as well, this is called a base. The big value, the normal font for our numbers, that is called the base. And the smaller value, right here and right here, this is known as the index or the exponent. These are the same words for the same thing. They're alternates, you can interchange them. You can either stick to index or you can either stick to exponents. And their plural forms are a little bit different. Index plural form is indices. And exponents plural form is exponents. So if you're explaining something, if there's just a little bit of an explanation required, you can use these plurals if applicable. So now that we know how we write an index or exponent and what it means actually, I'm gonna give you a little activity to solve. Please calculate 9 to the power of 10 and 4 to the power of 6. And the way to calculate this, assuming that you've already had your go, is to multiply 9 over and over by itself until you reach 10 digits of 9 multiplying by themselves. 1, 2, 3, 4, 5. That's the 6th 9, the 7th, the 8th, and the 9th. This is what it actually means. 4, the same case with 4. You're going to multiply 4 by itself 6 times. And this is what we're dealing with. By this on, it must be really easy to calculate. You can take out your calculator. You could solve it that way if it's in paper 1. Depends. But if you're not solving this with manually, I would like to show you a way you could do this with a calculator. And instead of writing like something like 9 into 9 into 9 into 9, you could just do it very simply by clicking 9 once. We know the base. Click on this button, which states x to the power. It has a little box on the top indicating an input for the exponent or the index. So I'm just going to click it, and it's going to give me a little blank box right here. I'm going to fill it with the exponent. So that is 10 in this case, and I'm going to hit equals. That is going to give me the answer. Same case for 4. Try it out with your calculator. It must have a symbol somewhere like this in the buttons. So click on that, and you have 4 to the power of 6 is 4096. So let me write these answers down. And 9 to the power of 10 is 34867844401. Now that was a big one, and it would be tedious to solve it manually and in a row. Now that we have seen a long number, you may have wondered previously, maybe in accounting, while studying accounting, or being subject to measurements in a physics exam or something like that. If you've studied science or handled data in some way, you may wonder that if there is a better way to represent long numbers. Now, long numbers can be big or small. They could be 0.000 something, or they could be 3480000, and it could go on the right way as well. But the principle behind this is we need a better way to represent these long numbers, no matter their scale. So scientists, fortunately, have devised a method, a standard method, a standard form to represent these numbers in. The standard form. This is also known as the scientific notation. So I'm just going to write that down. Scientific notation makes sense. A way to notate numbers in a scientific manner, in a way that's readable, understandable. And say you've been in an experiment and you're dealing with this much of bacteria. If I were to convert this huge number into the scientific notation, which I'll further elaborate upon, it would be this. Now, when it's converted, don't you think it's more compact and easier? You know how many zeros you're dealing with, and you know you only have to memorize this little digit right here, which is way better than like learning this whole list of digits. So what we're going to learn is actually converting this stuff into this stuff. Have you heard in maybe computer science that you're actually compressing your file? Something like that. We're compressing the number to be more readable, to be more convenient to us scientists and accountants and everyone, whoever is dealing with numbers. So right now, let's just jump into the method of actually converting the big number or the small number into scientific notation. So first of all, as discussed in the objective, the scientific notation or standard form comprises of this general form. It is a into 10 to the power of n. A here can be greater than or equal to 1 or lesser than 10. So A here should be ranging from 1 to 10, from 1 to 9, any digit from 1 to 9. And n here, the second variable, should be positive or negative. Right now we're just going to look at the positive side, so it could be positive or negative, right here, depending on the size or the scale of the number that we're dealing with. So if it's a huge number, for example, the population, the n in that case is going to be positive. And if so, it is a small number, maybe microscopic, maybe a size of a blood cell. So the example here would be the size of a red blood cell. So that in that case, it's going to be negative. N is going to be negative. So these are the two indicators. And the way actually to convert this, I'm actually going to put a huge number right here, which you're going to actually convert. So in a past paper example, the reference is on the side. It says that a mass of 1 grain of rice is 0.00002 kilograms. And we have to convert this into scientific notation or standard form. The first step we have to the first step for doing this sort of a question is to identify N in A into 10 to the power of N. Since this is a small number and not a big one, for example, 200,000, that would be a big number. This is a small number, so N is going to be negative. So I'm just going to note that right here. N is negative. Step 2 is actually to see the significant digits in this one, or the non-zero digits. So here it's 2, right? So I'm just going to write 2 right here. There's nothing else. For example, if it would be 2, 4, then I would write 2, 4, but it's only 2, so I'm just going to write 2. And that is going to be my A. So step 2 is identify A. In A into 10 into N. And then after that, what our task is to look at this decimal point and actually try to move it to the right side of this, of A that we've identified. So how many steps would this decimal have to jump to find its way to the right side of our A? Well, that will be 1, 2, 3, 4, 5. 5 steps. So we're just going to write that on the side right here for us and rewrite A. And since there is a multiplication sign between A into 10, base 10, with an exponent of N, then since there is a multiplication sign in the middle, we have to think, what can we multiply with A to create this number? And the general form tells us it's going to be 10 to the power of something. So I'm just going to write 10. And don't you think N is going to be negative because we already identified that? And we saw that we have to move 5 steps over here. How can we move 5 steps? What if we multiply this thing with 10, with like 10 to the power of 5, or 10,000, 5 zeros. If we multiply it with 10,000, or 1 with 5 zeros, what's going to happen? Well, the thing that's going to happen is we're going to move the decimal 5 spaces, and that's what we're trying to do. If we take our calculator out, if you check that out as well, if you multiply 0.00002 with 10 to the power of 5, or 100,000, you're actually going to get 2. So the more digits we have, the more zeros we have with 1 right here, the more steps we're going to jump with the decimal to the right side. So that means we're going to multiply 2 with 10 to the power of 5. But do you think it's going to be correct? We're actually representing this number right here. And if we compare this number with the answer this is going to give, 2 into 10 to the power of 5, that's going to give us a big number. That's not giving us this one. Can you point out what the error here is? Yes, this is n. We have already identified n to be negative in this situation because this is a small number. So n will be minus 5. So 5 indicating the magnitude or the number of steps we have to move on to the right side. And negative indicating that this is a smaller number. So now let's try with 2 into 10 to the power of minus 5. Is it going to give us that? Yes, it is going to give us that. So that is our answer for this one. So this is our scientific notation for this number. So we had a total of 3 to 4 steps here in total. And we're going to use the same steps for a bigger number now. Now, looking at a bigger number. So this question, the same question right here, it says China produces this number of tons of rice in 2002. The first step is to identify n. N is positive because this is a big number. It's on the bigger scale rather than the smaller scale. The second thing, to identify A. Now here's the mistake that you must have made if you were initially solving this question. You might have written A as 12, but we know that A should be lesser than 10. But that would mean that we cannot incorporate 1 and 2, the non-zero digits. So what we'll do in this case is we're going to place a decimal in between. And what that will do is actually put it into that range of A being greater than or equal to 1 and lesser than 10. The non-zero digits that we're looking for are there. So we're going to use 1.2 instead of 12. If in another question it was 24000000000, that is going to mean that you're going to use 2.4 instead of 24. If it was 366 with 9 zeros, say, you're not going to use 366 or 36.6. You're going to use 3.66 as A. So in any case, you have to fall into this range. Now, once we've done that, we've identified A, we've identified N, we're going to see the number of steps. So here we have the decimal to be right here. Instead of at the back of the zeros, it's after the zeros. So in this case, what we're going to do is we're going to try to bring this decimal in the middle of 1 and 2, since A is 1.2. Here it was only 2, and 2 as a figure individually has its decimal point on its right. So we move the decimal point of the figure given in the question to the decimal point position given in A. Here A has its decimal point in the middle of 1 and 2. We're going to bring the decimal point in the figure of the question to 1.2. So we're going to move 1, 2, 3, 4, 5, 6, 7, 8 steps backwards. So that's going to mean that n is 8. But is it positive 8 or negative 8? Of course it's positive 8 because this is a bigger number. So now we're going to check whether that's going to give me the same answer. And as you can see, it does give me that same answer. So this means that I've done is correct. You don't need to fall into the troubles of whether moving the decimal point right is going to give you a negative n, and moving the decimal point left is going to give you a negative n. You just have to focus on whether this number is big, large in scale, or smaller in scale. The smallest number in scale is obviously going to mean a negative n, and a bigger number is going to mean a positive n. That's all you need to keep in mind for n. I myself got a little bit confused with the whole right and left thing, so all you need to remember is the scale of the number. If it's smaller, negative; if it's bigger, positive. And that generally makes sense. You draw the number line here. If you go higher, you're obviously going to go on the positive side. If you're going to go lower, you're going to go on the left side. And if you look at that rule of whether the decimal point is moving leftwards, that actually is moving on to the left side of the number line. And I often thought the n should be negative then, but I later realized that that's not the case. And so it's easier to remember the other way. Now to a past paper question. We solved the first part on paper, and I actually improvised the second part to teach you the bigger number. This one is actually the second part of this question, so we're going to solve that. This is a daily life example, and all of these standard form question or scientific notation questions are going to imply a daily life situation. So here there is another one. The table shows the amount of rice grown in some countries in 2002: China, Brazil, India, and Vietnam. Calculate the difference in the amount of rice grown in Brazil and Vietnam. Give your answer in standard form. So one way you could do this is actually take the amount of rice grown in Brazil, this thing right here, this column right here, and Vietnam, and convert them to the ordinary notation. The normal notation that we use is ordinary notation. We convert that into ordinary notation, and then we sort of subtract them, and then we convert them back into the scientific notation. That's one way to do it. The other way is to use a calculator, but of course this is paper 1. If this is IGCSE, of course you can use a calculator and be done with it, and it's only 1 mark, but it's GCSE, so we'll have to do it manually. So I'm going to do the first way because many get confused with the more direct approaches. They're obviously going to be more simpler or shortcut ways, but I suggest that you do a way that actually makes sense to you, because math is all about making sense and logic. And if you provide the examiner with a strong evidence that you actually know how this is done, whatever way you use, it's not going to really matter. So if you're using the longer one that I'm going to be showing today, it's not going to make a difference. The only difference that it makes is that you have to save time. But for the sake of this video, I'm going to go through the longer one, and eventually as you have practice, you're actually going to solve this a lot more faster and in much more shorter ways. So first of all, I'm going to convert this into the longer form, so it's going to be 76. We're going to move the decimal to the right. We're multiplying, so that's going to make it a bigger number. And if it's bigger, then the decimal moves on to the right. So it's going to be 76, not 76, 76, 0. Not the 0. So this is going to be the ordinary notation. For Vietnam, it's going to be 2, 1. This is going to be the ordinary notation. If I take its difference, which is going to be 2, 1, 0, 0, 0, subtractive A 76, 7, 6, 0, 0, 0, 0, 0. And whatever that's going to give me, if that's not 1, 3, 4 with 5 zeros, then you've probably made a mistake here. And now we're just going to convert it back. And that's super easy once you've got the practice. You take the decimal right here and you move it to get your desired A, which is going to be 1.34 into 10 to the power of 7, 10 to the power of 7. So that is going to be our answer for this question. Extra practice, you could do this question right here and this question. It relates with the operations. In the previous one, we actually solved a subtraction operation. An addition one would follow the same method, but division and multiplication is quite easier than that. I'm just going to display it with both of these problems. I'm going to do this one right here. So a swarm of locusts contains 40 billion locusts. A billion is 1,000 million. A million means 10 to the power of 6. Write down in standard form the number of locusts in this swarm. So 40 billion is going to mean 1,000 million. So 1,000 million is going to be the same as this. And A is always lesser than 10. So A is going to be 4. And 10 to the power of 1, 2, 3, 4. 10 to the power of 10. So that is going to be our answer. In this case, each locust eats 2 grams of food every day. 2 grams. Find the amount of food eaten by the swarm in 1 week. These are the amount of locusts, and this is how much they eat. We have to find the total amount of food eaten. So we're going to multiply this with 2 grams of food eaten every day. That is going to mean, I'm just going to multiply 2 with A. 2 times 4 is 8. That is going to mean this. Give your answer in kilograms. Now this is in grams. In kilogram, I'm just going to divide it by 1,000 because 1 kilogram contains 1,000 grams. That is going to be the same as 8 into 10 to the power of 10 over 10 to the power of 3. But assuming that you haven't done rules of indices, you can just stick to this one. This is going to mean that this is going to give you an answer of 8 into 10 to 7. You can use your calculator, but if it's paper 1, you'll have to do it manually. Another thing that you might come across is multiplication of 2 standard forms themselves. So if it's 1.2 into 10 to 8 and say 6.4 into 10 to the power of 10, this is going to imply using rules of indices, and that's what I'm going to explain you in the next one. And similarly with division, 1.2 into 10 to the power of 8 over 6.4 into 10 to the power of 10. That's also going to imply the division law of indices. So I'm going to cover all this in the next video. But for addition and subtraction, you've learned what needs to be known. Here's another question that you can solve. Same concept. And this one. You can take a screenshot, you can note it down. Same principle, same concept. And if you have any question regarding these problems, you can pop them down in the comments below. We can solve your problems out. And with that, I'll end this video. Bye.